Hi, welcome everyone. In this video, I'm going to show you how to do iterative forecasting in Excel, and it's just a continuity of the previous video where I showed you how to do univariate forecasting in Excel. So in this video, what I did is that I just copied the forecasting file that we discussed in the previous video. I will add the link in the comments. In this video, I'm going to show you how to optimize the weights in a way that it minimizes the residuals or it makes the residual error as near to zero as possible. So first thing I did is that I converted the forecasting error to absolute forecasting error so that I can minimize it to zero. Okay, otherwise it will minimize it to minus infinity. Second thing, in your Excel, what you have to do is go in your options, and in your add-ins, you have to add in the solver add-in. When you click it, you press go here, okay? And when you press go here, it will ask to add, so you have to tick it. So for me, it's already added. So when you have added it, now you have to go and do the solver function. Before that, what I've also did is that I changed the above formula to 1 minus, it should be 1 minus and the other weight. So that the sum is equal to 1. So what I did, I press solver. In that, your objective function, that is the error, absolute error, that you should minimize. So I select this one, that it tries to minimize, I set it here, minimize. And then which cell it should change, it is this one. Okay, so it will initially change this cell in a way that the answer of this cell should be 0. But what should be the limit? That's called constraint. So I've already added one constraint, so I will show how to did it, how I did it. I press change, and I have to select this cell as a reference, and then say it should be less than equal to 1. It should not go beyond 1, because if it goes beyond 1, the other weight will become negative. So when you do it, press add and OK, or what you call it, cancel, so that it's only one constraint here. Then what you do is, this is the linear programming that we already studied, or in other words, in the mathematics, it's called constraint optimization. So this is an objective function, and that we need to minimize, and this is the this is the objective outcome, the Lagrange, and these are the inputs, and these are the constraints. So you do nonlinear optimization. Okay, so you could do linear optimization, but why we are not selecting linear? Because if your outcome changes linearly with the changing variable, then you should do linear programming. But since our outcome is absolute value of forecast, and it can be negative or positive, so technically it's non-linear, because firstly, when you increase the weight, it will reduce, but when it goes to negative, it will tend to increase again in terms of modulus value. So that's why we pick non-linear. So when you press, you need to make sure it is tick yes, because it should not be negative. When you press solve, it will say that solution is found. Okay, so you need the output. So you select all the reports here, and then press OK. So you will notice here that what it has done, it has selected this value 0.77, and it has led to uh, no error. Okay, so no zero error. Why? Because it has been able to forecast the exact number. Okay, using these weights. Okay, so this way your forecasting weights are automatically corrected. So if you use this formula for your business idea or any approach where you want to make sure that your forecasts are your weights are optimized to your historical data, you apply this approach to make sure you get the correct weights. You can see the reports. So we'll start with the answer report. It says that the original value is started from the 1.6, the outcome value to 0. Okay, and it took it 0.157 seconds, and So the original value for the input was 0.6 and it led to this value. So it's a continuous number. So the constraints, this was the constraint value and this found it. So it is within the constraint that we suggested. So it is a non-binding. What is meant by non-binding means the outcome that we want to achieve, that is 0, is achievable within the boundaries that we set. The model did not require to go beyond 1 to solve the answer. Okay, so slack means this much number left. So this input is this much under the within the boundary, and then the sensitivity report. So final value is this, and outcome is this. So no constraint that were binding. So limits. So this is the final value. This is the final value of input. Its lower limit is 1. If you apply 0 as a lower limit, the outcome will be 7. If you apply 1 as an upper limit, the outcome will be 2. So it gives you all the constraint optimization answer. Luckily, it was non-binding. That's why there's nothing very technical to read here. So I hope you understood this video. You can try this. The link to the file is available. You can try this on applying on the three period weighted moving average function, or even on the exponential smoothing function by changing this value. I hope you will learn how to first of all forecast and then find the optimal weights that can improve the forecast value, and you understand how in the real life it can be applied. You first of all get the data of the business, and then get the problem which data you need to forecast, then apply any weighted moving average or exponential moving average formula, and then first of all do the testing on one value, means you apply it on one future value as a forecast, and then optimize your weights, and then this formula can be used for real-time forecasting. In this example, we had the data available. Now, since the formula is here, what we can do is we can extend it to forecast more values, forecast the future data. Okay, I hope you understand the application of forecasting models in the time series data. Thank you.